Okay, we're going to talk about just some general programming languages, terms, vocabulary, concepts, things that maybe I should have put in an intro lecture. I wanted to get started with being able to learn our code stuff, so I started with that earlier. But you can imagine maybe this is the intro lecture of a programming languages course. And I'll start with these slides here, 3 useful categories of conceptualizing a programming language. In particular, learning a language involves syntax and semantics. Those two are really standard. You'll see those in every programming language book. And I think it's kind of nice to throw in that, in addition to those two things, making one language different from another, there's pragmatics, which is a very real-world issue of, hey, I understand the syntax and semantics of both languages. They can both do things roughly equally as far as the language goes, but there are certain reasons maybe why I'm choosing Python. Maybe it has awesome libraries out there for doing math, or I really want to use Racket for this reason, or I'm really using C++ for that reason. And those all lump under pragmatics, which can be IDEs, what libraries are out there. It could be things like, hey, everybody else on my team at work knows this language and not that. Well, okay, we're going to use this language. In this class, we're not going to talk much about pragmatics, and I'll throw in certain ideas now and then, but it's not going to be a focus of this course. We'll be a little bit more traditional and talk about syntax and semantics. Okay, so syntax are the grammar rules defining a program. What is a valid program? When you're in Java and you compile, you can think of compiling. One thing that happens then is, hey, this big piece of text, does this follow the grammar rules of Java? Yes or no? And if not, you'll get a syntax error. Okay, there are other errors we can get, but syntax error is, hey, you don't follow the rules. And we have some, we've talked about the syntax in Racket of calling a function, open paren, function name, then several, one or more expressions, close paren. Or in Racket, we talk about the syntax rule for defining just a name, open paren, and define, and then some identifier, and then any expression, close paren. Okay, and we have the same thing in Java. I'm going to zoom in here, and the screen capture actually gets that. In Java, how do you declare an identifier in Java? Okay. And you might go and look up, you might have seen something like this in your Intro Java course. Hey, an ID declaration, and the square brackets might mean, hey, this is a non-terminal. You don't actually write ID decl, you replace it with a particular ID decl. What is a rule for writing ID decl? Well, you can have a modifier, actually maybe 0 or more modifiers, followed by a type, followed by an identifier, followed by semicolon. The semicolon here, again, we've mentioned that might be a literal semicolon. If you don't have a semicolon in there, it ain't an ID declaration. Or the other way you can do it in Java, and this is not comprehensive Java, I'm just taking a small subset that will sound familiar. You can have a modifier, 0 more modifiers, followed by a type, an identifier, an equal sign, and then an expression, semicolon. So we're talking about things like int n, semicolon. That's an example of this first time. 0 modifiers, followed by a type, followed by an identifier, followed by a semicolon. And I could also have, public double x, okay? In fact, when I say modifier, the ... is already, we'll come back and see more about this BNF syntax. A ... is going to be 0 or more of modifier. What is modifier? Well, modifier is one of the following, and these are not in square brackets, these are literal. Either the word final, or static, or public, or private, or protected, or synchronized. And again, what I'm putting here is not the actual legal Java syntax, just suggestive. But the actual Java syntax is a little bit more complicated about these things. Okay, but regardless, yeah, so it might say, oh yeah, final, private, static, and an identifier, m gets math.square root of, oops, I forgot something. I forgot to go ahead and I had a bunch of modifiers, final, private, static, and then I had an identifier m. I better have a type in between them. Okay, so, and now a pragmatic thing, I'll try to use variable names like x, y, z to represent doubles, and I, j, m, n to represent integer amounts, purely as a pragmatic social convention. Okay, unless I have reason otherwise. Okay, so this here might be, again, a legal declaration in Java according to this grammar here. So, again, we have the syntax for declaring an identifier in Java. What is a modifier in Java? How do you invoke a method call in Java? And it's going to be, you hopefully won't be too surprised to make a method call in Java. You have I'm going to say expression dot, and then a name, and then open paren, and then inside the open paren you can have 0 or more expressions. Oops. Okay. Gosh, what is an expression? We're begging that question. Don't worry about it. What is expression here? Okay. And so in particular, you may have thought that a method call always had to be a variable name followed by a dot, followed by the name of a method. And that's not technically true. You can have any object. Yeah, well, okay, that's a runtime concept. In the source code, you can have any expression followed by a dot, followed by the name of a method call, and that's going to be valid. So in particular, something like this is a valid thing. Let's go to start up a JShell here. JShell is new with Java 9. Let me just type in expressions, and I'm going to go ahead and type in hello.substring of 2, 5, and it gets lilo. Okay, so notice that I don't need to take the string hello and make a variable that holds hello, call that, greeting, and then say greeting.substring 2.5. No, I just have the string literal there. And in fact, you won't be surprised because you can go ahead and do things like this whole thing returns a string, and I can go ahead and say .length, and you're not surprised at that at all. You might be surprised that I had a literal string in front of my method call, but you're not surprised here I'm calling the method length, and the thing before that dot is a whole big other expression. Okay, so, okay. Anyway, that's just sort of previewing some of the syntax and things we will be looking at later. I want to go back and just sort of emphasize, hey, syntax is the grammar rules defining program. Semantics is what does it actually do, okay? In everything I just talked about, I didn't talk about what it means to declare an identifier. What does that mean or do? What does it mean to call a method? That I've explicitly ignored when talking about syntax. When you get a syntax error, it doesn't care about what any of that stuff does. It just says, hey, did you follow these rules here written down in this grammar? And it specifically avoids thinking at all about what it's going to do. So dividing by 0 might be something that you don't want to be doing. It might be an error at runtime. It will never be a syntax error. You can type 4 divided by 0 in Java, and it's not a syntax error. Okay, it will give a runtime error. Semantically, it says, hey, something's gone wrong here. Okay. So syntax and semantics, as well as pragmatics, all important. We'll be talking about all these issues, focusing on syntax and the relation between syntax and semantics. And again, in this class, we're going to be writing our own little language interpreter. So we're going to develop a syntax, have these rules for what a valid set of strings is, and then actually write a program that takes a piece of that syntax and does something with it, okay, according to some semantics that we'll write down. And I'll finish by saying that syntax tends to be very nailed down. Nobody argues about, hey, is this piece of text here a valid Java program or not, according to the rules of Java. They might argue about what it's supposed to do, okay? According to the language specs. Why? What does the substring call is supposed to do, that's written down somewhere in English. And you hope that that English description is clear enough and is actually fairly precise. It might be, but it might not be. English is a notoriously vague natural language. So there is a whole school of programming language, semantics, of saying, hey, can we formalize this? We don't want people arguing. We want to have our language really nailed down so it's really clear what it means, and we don't have any doubt anywhere. It should be machine checkable what something means, and not just, hey, does my Java compiler really match this 200-page book? I can grab this because we're in my office. Here we are. Fourth edition. Okay. Does it really match this 800-page book that is all about, here's a section on final fields. What are final fields supposed to be like? And it's a bunch of English. Does the Java compiler, does my Java runtime, does my JVM actually enforce all this stuff? Yeah. People doing programming language semantics might be saying, hey, can we prove that my runtime system actually enforces everything that was in that specification document for the language? And maybe my specification document won't be English, and it'll be some other more formal language like our syntax was. Okay. And I believe reading once somewhere, but I tried to look it up later, couldn't find it. Then Algol 60, smart people coming up with some of the early languages, they came up with the syntax. Their semantics was actually, it was written in English, like things still are, but it was actually quite vague, and there were programs you could write and give to different people on the Algol 60 committee, and they would disagree about what that program was supposed to do. And these are the guys designing the language saying what the semantics are supposed to be. So just keep in mind, semantics is currently held at a much lower bar than syntax is. Syntax is very clear. Okay. And let me just, any more notes on this slide before we pause? No, I think we're good. So yeah, let's go and look at some more specific terms in the next video.